So the types, now that we worked on solving, we're going to work on something called the discriminant, which is part of the quadratic formula, and what it tells us about the solutions. So the title of what we're going to talk about today is the discriminant. And just so you're aware, the discriminant is b squared minus 4ac, which hopefully that looks familiar to you. So as if you haven't already done so, then the graphic that I gave you can just go right at the top of our notes, because instead of us drawing those pictures, I have 3 sample equations and the 3 things that can happen when we're solving a quadratic. So the 3 things that could happen when you're solving a quadratic are that it's possible that, like this first one, has how many x-intercepts or solutions? You can just do it with fingers if you want. How many x-intercepts or solutions? Okay, so I'm seeing us put 2 there. Let's circle them. Okay. And so one of the things that could happen is it's possible that we call these zeros, but we also call them solutions. It's possible that there are 2 real solutions or x-intercepts. When you are using the quadratic formula, the reason why these answers are here is you guys in the opener today did quadratic formula, right? If you were looking at a graph of what we had in our opener, what you would have found was that 1 and negative 2.5 would be where they cross the x-axis. That's what the quadratic formula finds for us. But there's a shortcut way in the quadratic formula that you can figure out if it has solutions that are real or not, or how many they are. And do you remember you got 49 under the square root? Yes? Okay. When you are doing the portion under the square root, the portion that's under the square root is b squared minus 4ac. That's what the discriminant is. If you're wondering what's that word discriminant, it's just this. Whenever that's positive, a positive number, that is going to produce something that has 2 real solutions. And so that's how we tell how many solutions something has without doing the whole quadratic formula. We can just check that b squared minus 4ac. Okay? And as long as it's positive, it's going to always produce 2 real solutions. Okay, here's a second example. Okay, in this example, can you just with fingers tell me how many solutions that has? Good. So you're figuring out when I say solutions, I mean, okay, x-intercepts, and I saw you guys have 1 finger up because this has 1 real solution or x-intercept. And when something has 1 real solution or x-intercept, that discriminant actually is exactly equal to 0. So that's going to occur when b squared minus 4 times a times c is exactly equal to 0. And the reason why that happens in the quadratic formula, I'll just show you. You don't have to write this down, okay? If I would add or subtract 0 to something, so let's say I had like 5 plus or minus 0 divided by 2. That's how the quad formula goes, right? So square root of 0, 0. What does that give you? Just 2.5 both times, right? So when we have a discriminant that is exactly equal to 0, that's only going to produce 1 real solution. Okay, so then the last scenario. How many solutions or x-intercepts does that last graph have? Okay, it is possible to not have any. And so this has no real solutions. I'm going to say something about this in a minute because I think 2 weeks ago, not last week, but a couple weeks ago, we talked about imaginary solutions. And it still has imaginary solutions, but it has no real solutions. And that happens when b squared minus 4ac is less than 0. So you're going to get that discriminant is a negative value. Okay. Now, what I want to add to this last one is there are different kinds of solutions too. Well, I'm going to add first this. If there's no real solutions, that does mean there's two non-real or imaginary solutions. So there's still two of them, they're just non-real. They would have i's in them. The letter I, they would have the letter I in them. So they're non-real. Okay. Just so we're aware, there are other kinds of things that we ran across. In our opener today, we got, for our discriminant, we got the square root of 49. And what happens when we take the square root of 49? We get a nice answer, 7, okay? But also sometimes what happens is when we're doing the quadratic formula, we get like the square root of, I don't know, 11. Do you know the square root of 11 off the top of your head? No. So sometimes we get those irrational answers too, and they're not exact, just so you're aware. They're still real numbers. They're just not always perfect squares. Okay. All right, so here's how this works. We're going to do like 2 examples, and then we're going to do whiteboard practice for a little bit. So right now, the only thing I want us to check is the discriminant. So my very first question is, how many, and I'm going to actually ask, and what type of solutions does x squared plus 5x equal negative 9 have? Okay, so first of all, to use quadratic formula or discriminant, this is not in the right form. What do I need to do first? Yes, we learned that in the opener, hopefully. We're going to add the 9. And we are not going through the entire quadratic formula. We are simply checking the discriminant. Okay, so we're going to find b squared minus 4 times a times c. Would you do that, please, in your groups and see what number you get? So I'm seeing 25 minus 36, which is a negative 11. Okay. Looking, is that what you got as well? Okay. Looking up above, how many solutions and what kind? Well, first of all, I can say, no, it's negative, right? That's this. There are no real solutions. Okay, but they're what kind? Imaginary. So that what I would say is no real solutions, but 2 non-real or imaginary. Okay, so the question here is not to find them. I'm just checking the discriminant and telling about the solutions. Okay, does that make sense? One more thing. Then, the other thing is, what we could do is we could try to figure out what function values would have to be in order to get a certain type of solution. So, my second example is we're going to find a value of b so that 2x squared plus bx plus 18 equals 0 has one solution. Find a value of b so that 2x squared plus bx plus 18 equals 0 has one solution. Now, what I'm also going to tell you then is how, if you know this, how you can figure out how to make it have 2 and how to make it have none. Okay, would you flip back to the previous page? What does the discriminant have to equal for a quadratic to have one solution? 0. So what I'm going to first do is I'm going to write this statement. In order for this to be true from the previous page, b squared minus 4 times a times c has to equal 0. That's what we said. Okay, what do we know? Do we know any of these things? We are trying to find b, so we don't know that. Do we know a? 2. And do we know c? Okay, well, let's plug those in and see if we can figure it out. So we have b squared minus 4 times 2 times 18 equals 0. Can somebody evaluate 4 times 2 times 18 for me? Okay, so b squared minus 144 equals 0. You guys, you've done this before. Let's solve for b. I'm going to add the 144 to both sides, and I'm going to solve using square roots. So now I take the square root of both sides, right? What do we have to add to the front? Thank you, plus or minus. B can be plus or minus 12. If b is either a positive or negative 12, this quadratic would have one solution. Okay, so I have a question for you then. If I wanted to make this discriminant a positive number, then what kind of number, there's a lot of numbers that would work, but if b equaling 12 or negative 12 makes it exactly 0, what kind of number would b have to be to make it bigger than 0 then, in relationship to 12? Any thoughts about that? If I put 12 in here and I got exactly 0, what's that? Anything bigger than 12 would make this positive, or anything actually less than negative 12, because it's the same deal when they're negative. If I wanted to see when it would be no solutions, it would be things that would be smaller than 12, or between 12 and negative 12. Okay, just so if I ask those questions, which I will. All right, so all about checking the discriminant.